All right, well, let's go ahead and work through these problems. Probably the easiest way to do this is to actually just sketch the angle itself. Then we'll go up and try to figure out exactly where on the unit circle we are so that we can get this correct. So we're starting off with the sine of 10 pi over 7. I mean, one way to do this is to just think, here's what we're going to be doing, is we're just going to do that inner situation there. So 10 pi over 7, here's 7 pi over 7, and then, let me get rid of that. So 7 pi over 7 goes halfway around, and then 8, 9, 10 is not quite to the next thing, because 10 sevenths is a little less than 3 halves. 11 sevenths would be the other side, 11, 12, 13, 14. Anyway, I mean, if here we could do this, 3 sevenths is less than 1 half. That you can tell for sure. But anyway, so we're down here somewhere. So that sine is going to be a negative number. Not only that, it's going to be the same as this angle here. This is 3 pi over 7. So that the sine there will be the same as the sine over here, 3 pi over 7. And so let me get rid of all my mess here. So I'm going to find the angle whose sine is the same as this angle's sine. So the way I guess the way that I'm going to do this is whenever you're dealing with a sine, well, here, let's just do this one, and then I'll talk about a rule that you could use, because I know some of you just want to know the rule. Anyway, this is going to end up being the negative 3 pi over 7, because this angle here is in the range of arc sine. So now let's go up here to this circle here. And so maybe you could think of it this way, is that when you're dealing with the arc sine will always give you an angle over here somewhere. So in this range, so arc sine will always end up being between negative pi over 2 and positive pi over 2. And so if you end up with an angle over here somewhere, what you're going to want to do is fold it over. So just put it over here. So shove it over there. Like if your angle was, here, let's get rid of those. Let's say that your angle went up here somewhere. Then you just stick it over here and do the mirror image, if you will. So just do a mirror image across that way, and you'll be all set. Let's see if this will work for us with this one. So the first step is to figure out where negative 8 pi over 5 is. So here's negative 8 pi over 5. So here is 5 pi over 5. And then you need another 3 pi over 5, which is a little bit more than 1/2, so it'll be up here. So that angle is in the correct area. It's in this, where the arc sine, the range of the arc sine function. So this will be negative 8 pi over 5. So I just have to figure out what this angle is. That'll be 2 pi over 5, and that'll be the output for this one. Whoops. Oh, come on. So I guess the rule that I would, if you want to have a rule, I hate having rules, but if your terminal side is to the left of the y-axis, it doesn't matter what angle we're talking about, it could be some crazy angle, then you need to figure out your reference angle and then move this back, basically just reflect it over the y-axis, so that you get the answer will be in the first or the fourth quadrant. If your angle, where am I going to get rid of those? Let's just get rid of all of this. if your angle happens to be in the correct area, like let's say I go like this, like that. So that's in the correct area. Then I'm all set. The main thing is that I need to make sure that I figure out this reference angle here. So this is whatever it is. So subtract 360 from the original angle. Okay, so that's true for sine. It's also true for tangent, by the way. Tangent's a little different. So I guess we'll have to do some tangent problems. So let's do these cosines. Cosines is different. So with cosine, let's see. Let's go back up here to this circle. So with cosine, the cosine is always going to give you an angle. Arc cosine will always give you an angle that's in the first or second quadrant. It'll be up here. So this is the arc cosine. It's always up there. So now we just have to worry about if we end up down here or down here, we're going to have to push those angles up. It's the same sort of idea as what we got when we were doing the arc sine. You just have to, it's going to be a little bit more tedious to do the quadrant 3, and I guess quadrant 4 will be a problem as well. But let's see where this ends up. 21 pi over 11. So we start with 11 pi over 11, which is half a circle. And then we go another 10 pi over 11, which takes us almost a full circle. So you're right here. So that's 21 pi over 11. So what we're going to need to know is we need to know this here is just pi over 11. If you think about it, if I did a full circle, it would be 22 pi over 11. Then we have to recognize that we're in the wrong quadrant. We're down here, and I need to move this thing up there. And so I'm going to have the same angle, but it's going to be up in quadrant 1. So this will be right here, and this will be also pi over 11. So that'll be the answer, pi over 11. This one, once again, I think I made this mistake. This here. Let's do this, 21, and I bet I could. There we go. Obliterate that. There we go. That's the way it's supposed to look. 5 pi over 21. That's not very interesting, though, now that I look at it. But we'll do it. So first step is to draw that angle, 5 pi over 21. So that's actually a pretty small angle. And so since you're already in the right area, that's going to be your answer. Let me just make up one more just to make sure that we can do this. So let's say I'm going to do the arc cosine of the cosine of, hold on a minute. Just make sure that this works out nicely. How about 9, 4, 13? Yeah, try this one. Negative 13 pi over 9. Let's do that one. So let's draw this angle. Negative 13 pi over 9. Here's 9 pi over 9. And then we're going to go another 4 pi over 9, which is 4 pi over 9 is just a little bit below pi over 2, so you're right here. So this is going to be negative 13 pi over 9. So let's see, this angle happens to be in the right zone. So it's up here in the first and second quadrant. However, it's not written the right way. So I've got this angle, it goes up here, and it goes around that way. I need to figure out how to write this angle. But that's not too bad, because notice that together those two angles make a full circle. So to get this, what we're going to do is we're going to just figure out, let's see, we'll do 2 pi minus 13/9 pi. So let's see, 2 pi is the same as 18/9 pi. Oops, I'm off the page. And that'll be 5 pi over 9. And that's what that'll be. All right, onward to tangent. So tangent. Tangent feels similar to the sine, but the big difference is that the way that we're going to figure out, like, reflect things over. So we'll start with this one, 12 pi over 35. Okay, that one's actually pretty easy because 12 pi is a little less than half of 35. So 35, half of 35 is 17.5. So this is going to be something like this. So the answer is just going to be 12 pi over 35. So that one was kind of boring. Okay, let's see if this one's more interesting. A little bit more. I may have to make up a new one for this as well. Okay, so negative 39 pi over 19. Let's see, so here's 19 pi over 19. We're going negative. And then 38 pi over 19, because 38 is 2 times 19. And then a little bit more. This is kind of interesting. Okay, so that is 39 pi over 19. So if you subtract off 2 pi, you get this little tiny reference angle here. That's going to be pi over 19. And so since that happens to be in the range of values for the arc tangent, then we're just going to, here, so arc tangent is similar to arc sine. And good enough. So this is the angle we're dealing with. So that's going to be my answer. Is that negative pi over 19, because you're going down. Okay, so the only other thing, just a little minor glitch with tangent, is that it hasn't shown up in the 2 examples, is if you end up with an angle that is over here somewhere, let's say it's over here. If that's your angle, I don't care which direction I go. I can go like this, whatever. That's not in the range of values for arctangent, so you have to move it into the range of values for arctangent. The easy way to remember this is that everything is positive. Here, the sine is the only thing that's positive. Here, tangent, and here, cosine. So tangent will be negative up there. So tan is going to be less than 0. And that's also true down here in the 4th quadrant. So to do this, what you're going to do is you're going to move your angle backwards, and you kind of just, extend the ray back into that quadrant. So for example, if this were, I guess I'm going to have to make one up now since I've got it drawn there. Let me just think for a minute here. We'll go with 19ths again. 38. How about 38 plus another 17? So what's that? 48, 55. 55 19ths. 55 pi over 19. Okay, so I need to know what this little tiny angle is, that reference angle. So if this had extended all the way around to be where this is, like right to there, then the angle would have been 3 pi, which is the same as 19 times 3. Why did I pick something so complicated? 57 pi over 19. So that little wedge there is the difference between 57 pi over 19 and 55 pi over 19, which is 2 pi over 19. So I need to make sure that that matches over here, but it's going to be negative because I'm in the 4th quadrant. So if you end up with an angle that's in the 2nd quadrant, you're going to move it to the 4th quadrant. If your angle ends up over here, and it's a tangent. That's tangent's positive down there, so you just push it up into the first quadrant. All right, I think that's almost done. I guess there's just a few extra problems here. Main thing to note here is that things like this, if you see that, arc cosine of radical 3 is bigger than 1, so this does not exist. dne, so the whole thing won't exist. But otherwise, as long as for sine and cosine, as long as x is between 1 and -1, then what you got, that's what you see is what you get. Like if you're doing it this way, sine of the inverse sine. So notice the difference here. These were, the inverse sine was on the outside. Here, the inverse sine is on the inside. So as long as you're between -1 and 1, for arc cosine and arc sine, you just copy that number down. Arc tangent doesn't matter what number, big or small as you want. It'll just be like that. And that's it. So I hope this helps. Don't forget to like, subscribe, and tell your friends.